death-defying danger. Brutal battles of man versus machine.
Corner workers were yelling, "Oh, this thing's gonna blow, it's gonna catch fire."
And breakthrough innovations pushing the limits of human survival.
And all I could think about was just the scraping of the car on the tar mat there at Daytona, and it just kept going and going.
In these high-octane fast lanes, the world's most daring drivers put their lives on the line and high-tech engineering to the ultimate road test.
Every time you sit behind the wheel of a race car, you are taking your life into your hands.
All in the cutting-edge crash science of some of the world's fastest cars. Skids, flips, spins, and bone-crushing collisions. For engineers, keeping these ambitious racers alive is a constant challenge, driving revolutionary design innovations and high-tech safety solutions.
Oh, we got one on the roof.
To its millions of fans around the world, auto racing is an addictive adrenaline rush. Popular competition series like Open Wheel Formula, Grand Touring, and Stock Car showcase different car constructions and engineering. Some built strictly for racing, some modified, souped-up versions of production models. All share an obsessive need for speed.
What I think attracts people to motorsports in general is the excitement, the unpredictability of it, and the understanding that race car drivers are typically operating at the limit. So it's a sport that has a lot of unpredictability and excitement, high speed, power.
I thrive on the strategies of the race and trying to get that guy, to win the race.
On the world's toughest racetracks, intense rivalry equals intense risk. When a passionate will to win takes a terrifying turn, a car's construction means the difference between life and death.
Corner workers were yelling, "Oh, this thing's gonna blow, it's gonna catch fire."
June 2006. The event, Grand American Road Racing's Rolex Sports Car Series. The track, the challenging, nearly 2.5-mile Mid-Ohio Speedway. The cars, closed cockpit GT or Grand Touring powerhouses, made from elite, high-end production model sports cars, customized inside and out and turbocharged for maximum racing speed.
It was the most fun you can have just from driving a car because of the pure horsepower, the speeds you attain, the adrenaline that goes through your body when you go through high-speed corners. They are awesome vehicles.
Talented young driver Joey Hand is racing with the prestigious BMW North America team. Hand believes his $150,000 BMW M3 will take him all the way to the winner's podium. It's a super-tuned race version of the celebrated street model, packed with a 430 horsepower mega engine, capable of over 160 miles an hour.
That's a street M3 on steroids. It's got big brakes, big gearbox, more horsepower.
As the race gets underway, Hand aggressively maneuvers into the lead. Late into the nearly 3-hour-long competition, he's locked in a bitter battle with ambitious rival Paul Edwards. Hand pushes his BMW to 135 miles an hour.
I drove the car back through up to the lead, and basically it was going to be very difficult for anybody to get that lead away from me.
Heading into tricky turn number 2, the racing rivals jam up with a slower pack. To get around them, Joey Hand moves to the inside. Edwards pushes forward, successfully passing Joey Hand.
Oh, they hit him! Oh, no!
Just as Hand careens off course into a monstrous multiple flip, turning over 12 times.
Very big accident. Very, very big accident.
before crashing hard, upside down.
You gotta hope for Joey Handy's all right. Multiple flips, gone over 6, 7 easily times.
I felt what I thought was fuel, oil, water, everything just dripping down me, running down my back, filling up the roof of the car. I could see there was oil separating with water and all this different stuff, and I thought, man, this is bad.
Rescue workers rushed to the scene. At last, they pulled Joey Hand out of the wreck.
I don't think I got anything broken. I'm in pretty good shape. Meanwhile, paramedics are there going, we're life flighting you, putting IVs in both arms. They're like, we're gonna take you, sir. If you saw this wreck, it's the worst thing we've ever seen.
What went wrong, sending experienced driver Joey Hand into a horrifying multiple flip? The crash crisis point began with a bitter battle for the lead.
We were racing for the lead, nose to tail, first, second, third, bam, 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 right there. It was very easy for the spectators and the fans watching at home to see who was racing to win.
The race rivalry took a treacherous turn. At the corner, Hand and close competitor Paul Edwards hit a pack of slower cars. Joey Hand wanted to cut the turn tight as possible. He swiftly moved to the inside, but Edwards, on the outside, suddenly pulled in close behind Hand's right rear tire. So close, Edwards nosed Hand off the road, literally.
And his nose lifted the rear of the BMW and turned it at the same time to the infield. So I got wheel spin in the rear, and the car went to the infield. And from there, I was in the grass.
Even after losing traction and skidding off track, Joey Hand might have recovered, until a hidden hazard pushed him over the edge.
And I looked about 20 feet ahead of me, which is not a lot, going 135 miles an hour. I could see there was a rise from the grass level I was on to the top of that road. And I knew I was in trouble.
For Joey Hand, the uneven terrain off track was an unwelcome surprise. For the BMW, it was decimation.
The car went into some pirouettes slash barrel roll slash nose over tail, random stuff.
The sudden drop-off pitches his car up and over. High-speed momentum forcing the M3 to flip end over end, a horrific 12 times, smashing into the dirt with chassis-shattering impact.
The first hit was a big one. I remember missing the tail, like the car didn't even hit the rear end. And then it got very violent after that. It just got like ragdoll. I remember just getting whipped around and boom, 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 boom.
What's the solution to surviving a multiple flip like Joey Hand's? It comes down to crash-proof engineering. To protect drivers in a collision crisis, modern car designers want to limit gravity's impact force, or G-force on the driver, by ensuring the car takes the brunt of the beating. Their goal: an autoframe that could both absorb shock and keep it contained. Too soft a frame and the impact decimates the whole car. Too hard a frame and the impact channels to the most shock-absorbing object, the driver. It's an engineering challenge with the highest possible stakes.
Any kind of safety device that is built into the vehicle itself is very much dependent on the type of impact. Every special provision that is made to reduce the consequences of an impact typically will work well in a specific direction but not in another.
The breakthrough solution: crumple zones. In unibody cars like Joey Hand's BMW, where frame and autobody are a single construction, crumple zones offer strategically designed weak spots, engineered to give in to the worst a crash can dish out. In fact, in an accident, a crumple zone's most important job is to buy the driver time. Here's how. By crumpling inwards rather than resisting and rebounding, a crumple zone actually absorbs destructive energy, delaying and dissipating the dangerous impact as it travels through the car body. The slower that energy travels, the more it loses deadly force along the way.
The crumple zone is made up of a material that is designed to accordion, to compress into a shorter shape. And by doing that, what they do is they absorb a certain amount of energy, and at the same time they also give the vehicle some additional distance over which it can decelerate before coming to a stop.
Sudden stops is what hurts people, right? Concrete walls, things like that. I was able to get the energy taken out of the wreck slowly over a long period of time, 5-6 seconds, right? So that's what allows you to survive.
Today, using computer imaging and new construction materials, engineers continue to perfect the design of life-saving crumple zones, turning cars into collision shock absorbers. Joey Hand was extremely lucky. Though the accident totaled his BMW, the M3's crash-proof construction saved his life.
Sounds crazy. You know, I flipped 12 times, but I did walk away.
In a catastrophic crash, a raging blaze can erupt at any moment. Getting out alive comes down to milliseconds, and fast access to an endangered driver. Something racer Tim Mullen experienced in a flaming collision that almost ended his life.
It just seemed to take much longer than the actual real time itself. And yeah, eventually the bang came.
June 2000. The Formula Palmer-Audi circuit gathers for a critical competition round. Up-and-coming racer Tim Mullen wants to make a big impression. To move ahead in world Formula racing, he first needs to dominate here. But the Belgian racecourse Spa Francorchamps is a treacherous test of skill.
Mention the name Spa Francorchamps to an inexperienced or rookie driver and you can almost see the fear written in his eyes. It's a tremendously challenging course.
Just like his 21 competitors, Mullen races Formula Palmer-Audis. As with all Formula race cars, the Palmer-Audis are rear-engine open-wheel vehicles built for master maneuvers at high speed. These cars are part of a unique competition circuit with an unusually level playing field. An identical fleet owned and operated by a single manufacturer.
It was unique as well because everything was run by Palmer Sport, all under the one banner. It meant that one team couldn't spend more money than another team, and so every driver had the same equipment. It would sort of try to be fair to everyone throughout the championship.
The British pro driver knows the Belgian racetrack's notorious reputation, including one of the most dangerous corners in all of car racing. Named for a local river, it has an ironically gruesome title, Eau Rouge, Red Water.
Eau Rouge is the best corner, one of the most famous corners in the world, and it's just because of the elevation change, the way the road goes up and goes really steep. But you're turning at the same time. It's a bit like a roller coaster.
As the race begins, Mullen's in top form, moving fast through the pack. 6 laps through the 9-lap race, he's facing down the Eau Rouge straightaway. The racer barrels down the stretch at a dizzying 155 miles an hour. Then, when he least expects it, Mullen crashes into a barrier at top speed. The car bursts into flames, sending spectators running from the noxious smoke and threat of explosion. Inside the car, Mullen is conscious, but the clock is ticking. Trapped in the burning wreck, every second is a countdown to catastrophe.
The The single most important reason why drivers should not remain trapped inside their vehicle for too long is fire. The difference between life and death in the event of a serious accident could be fewer than 10 seconds.
I remember, right, there's no point in me holding onto the steering wheel because that's not going to do anything. So I just remember taking my hands off the steering wheel, I folded my arms like that and just basically waiting for it. And it was like slow motion, and it just seemed to take much longer than the actual real time itself. And yeah, eventually the bang came.
Rescuers surround the blazing car. To get Mullen out alive, high-powered fire extinguishers must contain the fatal flames. To everyone's relief, Mullen's carried to safety.
Once they got me out of the car, they put me on a stretcher. The doctors made just the precautionary checks that they normally do. I was just a bit bruised and battered really by the impact of the accident. And had a sore head for a few days and stuff, but you know, to come away with that was actually very lucky really.
What went wrong leading skilled racer Tim Mullen to crash and combust? Mullen's trouble started at the Eau Rouge corner. Bracing himself for the notorious blind turn, he strategically surveyed the competition.
Halfway down the straight, I looked in the mirror, saw that he was, you know, quite a bit back. Therefore, I thought, well, there's no need for me to even think about defending the line for the corner.
Mullen knew to treat the Eau Rouge stretch as a yellow flag. No passing, proceed with extreme caution. He did a quick calculation. Moving at 155 miles an hour, Mullen thought the rear driver needed time and distance to close the gap. He was tragically wrong.
Halfway down that straight, it didn't even enter my mind that he was close enough to do anything or to even challenge me. He really gained on me going down the hill.
To overtake Mullen, the driver behind him hit an acceleration device called a boost switch.
Some racing series have introduced the idea of this timed boost. The amount of boost or overpressure provided by a turbocharger is limited to a maximum amount. However, for a short period of time, the driver can choose to have additional boost. Push a button, get an extra 50 horsepower and make a pass. That's a very spectacular thing.
As the rear driver boosted, Mullen had no time to react. In that moment, the two cars made catastrophic contact. In open-wheel racing, when wheel touches wheel, it's a formula for disaster.
His right front wheel actually touched my left rear wheel, and that has that spat me off to the left, backwards, spinning backwards towards the barriers.
In the case of open-wheel race cars, you can, if you happen to have wheel-to-wheel contact, that typically results in an accident.
As he hurtled off course at breakneck speed, Mullen's only hope was to try to slow down and lessen the crash impact. Unfortunately for Tim Mullen, the Eau Rouge is flanked with gravel. Already out of control, once his open wheels hit gravel's moving, unstable surface, stopping became impossible.
When I initially hit the edge of the gravel trap, it actually made the car sort of airborne for a little bit, so I actually skipped over a lot of the gravel trap, which didn't slow me down at all.
What happened next sealed Mullen's fiery fate. While the exact cause of the blaze remains unknown, as Mullen's car collided, it most likely severed a high-pressure fuel intake line, a rigid metal tube carrying gas from tank to engine. The volatile gasoline fumes hit the car's white-hot 1,000-degree exhaust system. The result, a raging fire.
I remember seeing a flash of flame come up behind me and thinking, I've got to get out of here.
Fires and motorsports go together. you have a vehicle that is operating with very high exhaust temperatures, engine temperatures, and you're carrying a highly combustible fuel in the tank. So fires are going to happen. So it's absolutely essential that following an accident, the driver be extracted from the vehicle as quickly as possible.
For decades, engineers have tried to prevent crash fires like Tim Mullen's. One look at a car's complex fuel system, and the challenge is clear. Designed to mix the gasoline with air, burning the highly combustible fumes under intense heat and pressure, fireproofing every millimeter of fuel tank, gas line, and injection would be impossible. Instead, some designers turn their focus to helping drivers survive. The best way to get a driver out of a burning race car is swiftly and smoothly. But in crisis chaos, with an injured or incapacitated driver, this can be extremely difficult.
What the safety crews tend to do is to try to keep you and don't move in case you have neck injuries or back injuries. And then I think they just lifted me out of the car very, very slowly. It was like, I think, you know, a millimeter at a time as they sort of pull you out of the car.
Today, there's a solution. To save trapped drivers like Tim Mullen, Formula race car engineers experimented with ways of stabilizing an injured driver's body, protecting him from further damage during a rushed rescue. Designers unveiled a groundbreaking innovation, the removable cockpit. Constructed like a custom back brace, during car assembly, the removable cockpit's built to the racer's exact measurements. In an accident, the life-saving device becomes a rescue-ready stretcher.
How do you get a driver as quickly as possible out of a situation in which the vehicle may be catching on fire, the driver is injured? It's not uncommon to have designs that require the cockpit to be quickly unfastened and removed from the scene of the accident with the driver in it.
For Tim Mullen and other top racers, mortal risk is part of the job. But thanks to ingenious inventions like removable cockpits, they can survive the worst crashes to race again. In the world's ultimate fast lanes, a car's aerodynamics can go from ally to enemy in an instant, and turn a race car into an airborne disaster. For drivers, a car's ability to stay on the ground is a matter of life and death. As rookie racer Andrew Meyers discovered in a terrifying liftoff crash he'll never forget.
All I could think about was just the scraping of the car on top of the tarmac there at Daytona, and it just kept going and going.
Andrew Meyers is an up-and-coming racer on the American stock car scene. He's already proven himself in the NASCAR Grand National Division, a starter league for young pros with big ambitions. Anticipating his first ever super speedway event, Meyers needs his earlier experience to pay off in the big leagues, Daytona International Speedway.
I was fighting, running in a new series, running with a whole new set of competitors, people that I didn't know.
The rookie is ready to race in a custom-built stock car with a maximum horsepower engine and a super strong tube chassis. Tube chassis race cars have frames made from hollow steel rods. They may look like standard sedans on the outside, but on the inside, these 800 horsepower mega machines are all about speed. Lean and agile, they can burn up the track at 200 miles an hour. Just staying in control takes phenomenal focus.
On a track like that at Daytona, there's a car to the right of you, there's a car to the left of you, there's cars behind you, and you just have to be able to stay focused and make the right decisions to try to move forward.
It's February 2006, as top teams gather for the Daytona ARCA 200, the Auto Racing Club of America's 200-mile, 80-lap race. Daytona's extreme 31-degree banking and tight curves give the track a fearsome reputation.
When I got to Daytona, they explicitly told me there's no room for mistake. That track is unbelievable, it's a monster, and if you make a mistake, you don't really have the time to correct.
If you take a super speedway like Daytona, the challenge in that kind of track has to do with the extreme speed, the fact that a driver needs to maintain a high level of concentration at speeds that are in the neighborhood of 200 to 120 miles an hour.
As the cars zoom into the first lap, Meyers and 40 other racers jockey for front positions. So far, the rookie's holding his own. Tackling turn number 4, he pulls alongside another driver and veers dangerously off course. Hitting the bottom of a curve, his car suddenly takes flight, flipping over, skidding on its roof a terrifying quarter-mile.
The 7 car, Andrew Meyers down. Andrew Meyers coming.
Safety crews rush to the scene.
I could tell him, hey, I was fine, I just got to get out of this thing.
But what went wrong, causing Meyers to lose control and fly over? To understand how race cars like his can become airborne, we first have to analyze automobile aerodynamics and a racing strategy known as drafting.
I had some help from behind. I quickly went from about 30 feet behind his bumper to about 5 feet.
In racing, drafting is the closest thing to an aerodynamic free ride. Roaring around a track at high speeds, cars fight severe air resistance called drag. The more drag, the harder a car has to push just to maintain its speed. The only cure? Let another car do all the work by drafting, a kind of precision tailgating. Here's how it works. By tucking tight into the low-pressure air pocket directly behind the front car, a driver needs less horsepower to go the same speed. This frees up precious power for a sudden acceleration. It's a classic strategy that usually signals big plans, an aggressive charge.
Pulled out of line, out of the draft, thinking that it was a kind of a comfortable move to make. You also have to make sure that when you're trying to pass one, that you have a strong enough run, that you have enough speed built up. So when you pull out from behind him and all that air hits you head on, that the momentum that you have established and built up behind him carries on and you can make the pass.
But Meyers got into drafting difficulty and set himself up for an airborne accident.
As soon as I moved down to try to execute a pass, the cars that were behind me, they decided that they were going to move up and run with the other pack. So I was kind of left out by myself, out to dry, I guess, on the bottom. And I went around as smoothly as I could on the bottom until turn 4 came around.
As Meyers moved over, he hit dirty air. Dirty air is racing turbulence, the churning, uneven airflow breaking around a car, flowing along its sides. For a drafting driver, it can be a rude awakening.
And when you're in the draft, it gets pretty quiet. So when you pull out into the mainstream of the air, it becomes a lot more violent, I guess you could say, on the whole car itself, and it slowed up a little bit.
As Meyers hit dirty air, the rookie lost steady traction and started skidding out. In racing speak, it's called getting loose. Surviving getting loose is a matter of skill and nerve.
I felt the car sliding, and at that point I knew I was in a lot of trouble, so I pretty much hung on as the car turned sideways, and I thought I was like any other time when you come off a corner at speed, the car will just spin around and you'll stop.
Yet none of this would have forced Meyers up and over. The final destructive piece of the puzzle is another aerodynamic force called lift. Lift happens when the air pressure under a car becomes stronger than the air pressure above it. As Meyers' car angled outwards, powerful air pressure flowed through the open wheel wells under the car.
a vehicle that may be aerodynamically very stable when it's pointing forward, if it starts going sideways, now it can look very much like an airplane wing and take off in the air and become unstable, be lifted up in the air and result in a much more dangerous crash.
Without rear traction, skidding sideways, the air under Meyers' car lifted him up and over, as high-speed momentum sent him sliding down the track.
As it went upside down, I lost all the light coming through the windshield. So as I slid down the track, I mean, you knew it was bad, and you had no control.
For race car engineers, fighting dangerous lift is a huge challenge. Make a car too aerodynamic and it flies off the ground. For this reason, a car's rear spoilers and other fin-like extensions that spoil airflow help to propel air upwards, creating denser air pressure above the car, keeping traction steady. To fight lift even more, race cars like Meyers use barriers below the fender called front air dams to minimize air flowing under the car. Yet, air dams and spoilers can only go so far.
There have been some spectacular instances of vehicles taking up and going up in flight because of small disturbances, such as, for example, a bump on the road that causes the nose to point up for a brief period of time.
Hoping to find a solution to lethal lift, modern designers came up with an idea. Since lift can make race cars act like airplane wings, perhaps airplane wings were the answer. They created roof flaps. Like wing flaps that lift up during landings, car roof flaps create wind resistance. As a car with roof flaps skids sideways, air pressure pushes the flaps up, breaking lift, slowing the car down.
They're simple flaps that are normally, when the vehicle has the proper attitude, the proper direction, they're normally experiencing positive pressure, so the flap will stay down. But these flaps are designed in such a way that the moment the vehicle begins to experience lift, these flaps will come up because they no longer have a positive pressure keeping them down. Well, the moment they come up, they force the vehicle to experience additional aerodynamic drag, and essentially the vehicle will come back down.
In fact, Andrew Meyers' race car had roof flaps. Though Meyers flipped too quickly for his roof flaps to open all the way, had he not had any, he might have flown longer and further, crashing down even more catastrophically. And in the future, there may be an even better solution: 3 flaps. In recent years, top safety engineers have begun experiments to see whether a 3rd flap, placed on the front of the roof, might help cars like Meyers stay put, even when spun out of control. One thing's certain: on super speedways like Daytona, innovations like roof flaps can save lives.
Sometimes it's a racing accident where someone ran into you, or there's oil down on the track and you crash and you had a bad day. You look at it and you reflect and you try to improve on what happened.
But as long as Andrew Meyers and other ambitious pros push their cars to the edge of aerodynamics, accidents like his upside-down Daytona lift will always threaten. Race car drivers count on their skill, experience, and high-tech cars to protect them. But a sudden explosive crash can create deadly, flying debris and a desperate need to keep it contained. Something one pro racer found out the hard way in a terrifying accident that turned his car into a lethal weapon.
Something that might weigh 30 to 40 pounds, flying at 100 miles an hour, if it hits a spectator, that is likely to cause serious injury and sometimes death.
June 2005. Top Formula Palmer Audi pros gather once again at Belgium's Spa Francorchamps racetrack for another high-speed, high-stakes competition. Ambitious drivers like Greek racer John Ambirikos are all vying for a top finish. But maneuvering these lean open-wheel machines is a grueling challenge.
In the open-wheel Formula Series, there are many sudden changes in direction. So the peak loads in terms of accelerations for the driver are higher. Your body will be pushed to the right, pushed to the left, forward, back. So there is quite a bit of variety.
As the race begins, Imbiricos powers through the ranks. The drivers jockey for position at 155 miles per hour. Entering lap 3 of the 9-lap competition, Imbiricos stays razor sharp, pursuing every advantage. Suddenly, in a 3-car collision chain, Imbiricos is caught in a crossfire, with no choice but to hit a competitor head-on. Imbiricos spins out of control, plowing repeatedly into a retaining wall. The race car shatters into pieces. Only the cockpit remains, with John Imbiricos still inside. Crews rush to the wreckage, hoping to find the driver alive. Incredibly, Imbiricos escapes the crash intact, his car left behind in a horrific heap.
John Imbiricos was a very, very lucky man. It could have been a fatal accident. It wasn't, probably because of Imbiricos' split-second timing. He chose to go into the wall, but with catastrophic results for the car.
What went wrong, forcing John Imbiricos' car to break apart so violently? First, we have to examine the crash crisis point. Seconds before Imbiricos entered the corner, a 2-car collision spun one of the drivers completely backwards, leaving him powerless, facing the wrong way. One rival car was lucky to escape unscathed, but as the backwards car continued to slide, Imbiricos had no room to maneuver or time to stop.
They were literally nose to nose. He hit that with huge force, and it spun his car round, ripping the wheels off left and right.
At that point, Imbiricos was helpless to halt the destruction. At 155 miles an hour, impact and momentum combined with crushing force, twirling the car like a terrifying top. Each spin stripped off more of the Palmerauti. Most dangerous of all, the car's heavy wheels turned into flying projectiles, capable of lethal damage.
An open-wheel race car wheel might weigh in the neighborhood of 30 or 40 pounds. If you have an object that is shooting at 100 miles an hour and lands in the stands where spectators are sitting, you could easily kill someone.
What's the solution? To contain the danger of destructive crashes like John Imbiricos's, engineers turn their attention to the deadliest debris. To keep wheels from flying off, they wanted a structural support flexible enough for wheels to move freely, but strong enough to keep them car-bound in a crash. In the end, cutting-edge chemistry made it possible. Wheel tethers are thin ropes woven out of Zylon, a synthetic fiber stronger than steel. The tethers attach from the wheel hub to the chassis with a tensile strength capable of withstanding over 5 tons of load, or the amount of force sustained in a crash.
In the 1990s, different race series started exploring the possibility of tethering these wheels to the vehicle, maintaining the wheel connected to the body, while at the same time falling apart, coming apart at the suspension so as to absorb some of the energy of the impact. Other open wheel series progressively in the early part of this decade started adopting the same wheel tether regulations.
Unlike his Palmerauti, John Imbiricos was lucky to come out of this demolishing disaster in one piece. Wheel tethers protect fellow drivers and spectators from a race car's flying projectiles, curbing risk in a sport where danger can come from any direction. Up against extreme danger, race car drivers depend on their talent to survive. But no amount of ability can stop a monstrous mechanical failure. For one top pro, the result was a spine-shattering collision and a safety innovation that changed the sport forever. In world racing, Grand Touring competitions attract daring drivers. Engineers modified these compact sports cars for speed, not comfort, as British racer Shane Bland knows firsthand.
You're driving a car that in every single way is that much better than any road car you can achieve. You've got huge amounts of acceleration, huge amounts of horsepower going through the rear wheels. And in a GT car as well, they're very, very hot inside. The conditions are horrendous.
It's July 2001 at England's Donington Park racetrack. Top teams assemble for a critical round of the British Grand Touring Championship. Winning a tough competition the year before has earned Shane Bland the right to enter the elite race, driving a Marcos Mantis GTO, a modified $155,000 sports car with a 460 horsepower engine.
I was very confident in my driving ability and my car control. So for me it was brake as late as you can, accelerate as early as you can, and completely overdrive the car.
Up against 27 skilled competitors, Shane knows Donington's a difficult track, with an infamous hairpin turn called Red Gate.
Red Gate corner's a good corner. It's challenging in terms of getting it right. You can pick up a lot of speed there, you can make a lot of time there, you can lose a lot of time. It's just a case of getting the right technique through the corner.
As the race begins, Shane Bland pushes his Mantis to the limit, hitting 160 miles an hour. Into the final quarter of the hour-long race, the driver's in good form, muscling the high-speed sports car lap after lap.
It was all going as good as it could have been. We couldn't have expected more. So the car was handling well.
But as he approaches the infamous Red Gate corner, driver Shane Bland collides with a track wall. Then everyone's worst fear. The wrecked race car bursts into flame. As terrified spectators look on, the unconscious Bland remains inside, helpless to get out. With Bland unresponsive, rescue crews frantically work to extinguish the flames and get Bland out. Anxious pit crews surround the ominous wreck. An ambulance waits. At last, crews manage to move the critically injured driver onto a stretcher. For Shane Bland, the championship is over. With a broken neck and severely shattered spine, the race for his life has begun.
The vertebra was broken, shattered beyond sort of repair. It was a case of removing the shattered parts, which was a highly dangerous operation. And it was 50-50 of whether they'd either get me repaired, no problem, or I'd end up with being paralysed sort of from the neck down. So it was quite a tough time.
But how did Shane Bland's crash become so physically violent? To analyze the crash's devastating destruction, we first have to examine a race car's mechanical endurance. Most importantly, its vulnerable brakes.
One of the greatest challenges in all race cars is braking. Brakes, of course, need to dissipate a lot of energy and slow you down or stop you when you need to.
In cars like Shane Bland's, disc brakes work by using a clamp or caliper attached to a brake disc inside the car wheel. When a driver hits his brake pedal, the caliper clamps down on the brake disc, slowing the wheel. While highly effective, this clamping produces friction and heat. To reduce the friction, disc brakes wear brake pads made of more heat-absorbing materials like carbon or ceramic. But in a high-speed race, lap after punishing lap, brake pads can wear out or fade. For Shane Bland, fading became a life-threatening crisis.
So-called brake fading, which takes place when the brakes overheat and the friction material that is supposed to grab onto the disc doesn't have as much friction because of the overheating. So the real challenge with brakes is to come up with brake structures that are sufficiently light, but that can take extremely high temperature and the prolonged addition of heat through the braking action that takes place at every corner on a racetrack.
Throughout the race, Bland coped with failing brakes by pumping them, cooling down the brake pads. Then at the worst possible moment, Bland's stopgap strategy stopped working.
You pump the brakes and nothing happens, that's normal, you pump them again, and then you start to think, I'm not going to stop in time. And then you get to the point where you think, right, I'm going to have an accident here, and then there does become a point where, you know, you lose control of the vehicle.
Bland's fate was sealed. Total brake failure. With no way to stop himself, he hits the turn too fast to prevent catastrophe.
The last thing I can remember is deciding to turn into the corner early and focusing on the exit of the corner, thinking that's where I'm going to end up. And that was the last thing.
Instantly, the racer's head and neck snapped forward uncontrollably, victims of forward inertia.
From the moment the rescue crew got to the car, I was really in and out of consciousness. I can remember certain visions. So the first stage was I woke up, I still had the helmet on, and then you drift away, and the next time you wake up, the helmet's gone, the roof of the car they cut off, and they're starting to give me instructions on what not to do in terms of moving my neck.
Shane Bland's accident is an unforgettable example of how a mechanical failure can have catastrophic consequences. But in this high-risk sport, a completely crash-safe car is an impossibility.
Accidents on racetracks are simply an inherent part of racing. You're trying to extract the maximum performance from your engine, from your suspension, from your tires, from your vehicle as a whole. So it's inevitable that as you're pushing the limit, you may actually push beyond the limit sometimes.
To address unavoidable crashes, designers looked for a way Bland, and drivers like him, could avoid spinal injury. In an effort to protect the head and neck from violent shaking, engineers experimented with different body harness designs. After crash test trial and error, they built the HANS device.
One of the most important advances, if not the most important advance in motorsport safety in the last 20 years has been the HANS device. It quickly became mandatory in most major and minor racing series.
The HANS, short for head and neck support, is a strong but flexible shoulder collar made with Kevlar, the same material used in bulletproof vests. One of the most critical life-saving features are two straps which fasten to the racer's helmet. Like a seatbelt, the HANS restrains the driver's head in a sudden jolt, such as a collision. It's a stabilizing safeguard that means the difference between life and death.
As it became apparent that drivers kept walking away from accidents that 5 years before might have killed them, I think that that spoke loud enough for most drivers today to have accepted the HANS device as a real progress in safety.
The HANS device debuted at NASCAR in 2001, the same year Shane Bland crashed.
I think, from my point of view, looking back in terms of what could have been done better and still to this day would be the way to go is definitely a HANS device. I think it would have made a huge difference, to the point of it would have reduced my injuries to simply whiplash.
For Shane Bland, the HANS device only became widespread after his calamitous collision. Though recovered from his devastating injuries, Bland abandoned racing forever. And today, his championship crash remains vivid proof of how safety precautions can truly make or break drivers' lives. For the world's top racers, it's an addictive adrenaline rush. A high-speed chase to victory or defeat. Their cutting-edge cars run on revolutionary design and advanced technology. But as long as the quest for speed sends daring drivers to the edge of survival, safety engineers will have to keep up just to keep them alive. And push the crash science of some of the fastest cars on Earth.
the feeling it gave me, I can't get out of anything else I've done in life. It's simply the best feeling you can ever get.